So we've got the Chapter 7 homework that's due on Wednesday. So the first bit of it is just based on these two relationships here, that 1 foot gets you 0.433 psi. And if you go the other way with it, you can say 1 psi is 2.31 feet. Okay. So these first few ones are just based on that depth in feet to pressure relationship. The thing on these is don't make them too complicated, just keep them simple. 1 foot gets you 0.433 psi. So on 7.1, you can see that basic relationship. Don't worry about the shape of the tank. It's just depth to pressure. That's all you have to do. Number 2 there, you probably want the elevation difference between the 2 points, so the water tank and the hydrant. Number 3 there, you would find the pressure due to water and then factor it to account for the different specific gravity of the oil. Same thing with number 4 there. You've got a piezometer, which is just a tube attached to the pipe, 8.3 feet of fluid in the pipe, in the piezometer, I should say. And then we've got those 4 fluids with their different specific gravities. Mercury is often specified with the abbreviation Hg. That's the chemical symbol for mercury. I think it comes from the Latin name. Its specific gravity is 13.6. Okay. Okay, this one here, we're going to get into 1 psi is 2.31 feet. You ought to be able to kind of work through that one based on the difference in pressure and relate that to a height in feet. Okay, next one is pretty similar. You're starting off at 72 psi at the base of the building. Your water pressure cannot drop below 20 psi, so you can just set that to 20 psi at the top, the top of the building. Find the pressure difference between and convert that into feet, I think would be the way to do that. The next one, you have to do a little bit more calculations here, but what you're going to do on this one is you're going to look at that back pressure. That 42 psi is the pressure that the water exerts on the air as it comes out of that little tube coming out 234 feet below the ground. So by looking at that back pressure, the 42 psi, you can figure out how much water it takes to make that back pressure. You know the total distance is 234. You can find the height caused by that back pressure. You can subtract there and get the depth of the well, how far down it is from the surface to the water. Okay, this next one here, what we have is a burden gauge. We're going to measure the pressures with it at the bottom of the tank. Now what we want to do, we have the dimensions of the tank that are given. Okay. We want to know for these different pressures, 2, 4, 6, and 8 psi, how much water is in the tank in gallons. All right, I think you can get from the pressures to the height of the water, and once you have the height of the water, you should be able to find the volume and then convert that into gallons, okay? So for a given height, you've got a volume that looks something like that, okay? And you ought to be able to figure out how many gallons that is by doing some conversions. You'll have some conversion factors on the formula sheet for that. A hint on whether you're getting the right answers on those is that they should come out to be pretty much even numbers of gallons of water as you work through that. So, they're large kind of even gallon numbers if you round a little bit, okay? All right, the next one here, 7, 9, and 10 are similar problems. They're measuring vacuums. Now, there's a lot of ways to do these. I've just come up with this method over the years because it's systematic and it works pretty well. Basically, what's going on here is we have 3 different unit systems that we can use. We can use feet of water, inches of mercury, and psi. Okay, so that's 3 different unit systems. And then we can also set the 0 point in 2 different places. One place you can call 0 is what I call a perfect or total vacuum. No pressure whatsoever, like outer space, okay? And what that is, when you do that, we have this chart here that shows these different vacuum pressures. 0 is on the bottom of the chart, and you read up. That will work for absolute pressure and barometers, both mercury and water barometers. Okay, now you can also set 0 at your atmospheric pressure, average atmospheric pressure. If you do that, you measure down for vacuums. Okay, that's done for vacuum measured in inches of mercury and feet of water. It's also done for PSIG, what's called gauge pressure. You'll have negative gauge pressures when you measure down. So what you want to do on these, if you use this chart, is first determine what you're given. In this case, we're given 12 inches of mercury vacuum. Okay, that term means we're 12 inches below atmospheric pressure with mercury vacuum. Okay, so that will be this point right here, and we're measuring from 0 on the top in a vacuum going down 12 inches. Okay, now if we got 12 inches on this side, of course we have 18 inches on the other, because the total scale there is 30 inches of mercury. So we're going to have 12 on one side, 18 on the other. Now I like to work on percents on this graph. So I know that I've got 12 going down, the total is 30, so 12 over 30 is 0.4. That means we're going 40% of the way down, and that means we would also then go 60% of the way up. So this, and what I do is I mark that point. It's 40% of the way down from the top, and that leaves 60% of the way up from the bottom. And then I just draw a line across the graph. Okay. Now once I know that percentage, or you might call it a proportion, I can use any scale on that graph I want. So if I'm looking at, let's say I'm going to look at water vacuum here. I know that water vacuum is measured from the top down. And that's 40% of the total. Water vacuum goes from 0 to 34. I'm 40% of that, so that's 13.6 feet of water from the top measuring down. Okay. Now if I want to know PSIA, that starts at the bottom and works up. So that's going to be 60% of the total from the bottom up. The total is 14.7. 60% of that is 8.82 PSIA. Okay. So that's one way to do these, to base them on a graph, find the percentage from the top and bottom to your point, and then just draw a line across. Above the line in this case was 40%, below the line was 60. So that's one way to do these problems. Okay, 710 is similar. You use a similar approach. You just have to draw up your own graph on there. There's a copy of that graph on the formula sheet too. Okay, the last one here is a Utube manometer. You might still see a few of these around. I don't know. We've got two pipes coming out of the page. We've joined them together with this Utube shape, and we have mercury in the Utube. Okay. Now what's happening there is A is pushing the mercury, which is quite heavy, up towards B. Okay, we know the specific gravity of mercury, which again is abbreviated Hg on account of its Latin name, is 13.6. It's 13.6 times as heavy as water is. Okay, so what I would do on this would be to determine where the differences lie. The differences lie in this 14-inch interval here. Okay. Because above the top of that interval, I've got all water, and below the bottom of that interval, I've got all mercury. So this side really doesn't matter, nor does this side. What matters is where I have different fluids in the different pipes, and that's in that 14-inch span there. Now I want to get this into feet, so that'd be 1.167 feet. That's what 14 inches is. And then I just look at what each pipe is doing. Okay. What B is doing is it's pushing 14 inches of water towards A. That's 1.167 feet times 0.433 psi per foot. That's half a psi. Now A is doing a lot more towards B because it's pushing mercury up. You can run the calculations on that, and what you should see that 14 inches of mercury causes is 6.87 psi. So A is pushing 6.87 psi towards B. B is pushing 0.5 of psi towards A. So the difference is the pressure difference between A and B. It's 6.37 psi. So you probably have to do a little bit more on that to confirm the psi value on mercury. All right, so that's stuff's due Thursday. Keep in mind that the answers to most of the problems are on Moodle. So you can go ahead and check your answers with the numbers in Moodle.